Alfred Lothar Wegener was a German polar researcher, geophysicist and meteorologist. During his lifetime he was primarily known for his achievements in meteorology and as a pioneer of polar research, but today he is most remembered as the originator of the theory of continental drift by hypothesizing in 1912 that the continents are slowly drifting around the Earth. His hypothesis was controversial and not widely accepted until the 1950s, when numerous discoveries such as palaeomagnetism provided strong support for continental drift, and thereby a substantial basis for today's model of plate tectonics. Wegener was involved in several expeditions to Greenland to study polar air circulation before the existence of the jet stream was accepted. Expedition participants made many meteorological observations and achieved the first ever overwintering on the inland Greenland ice sheet, as well as the first ever boring of ice cores on a moving Arctic glacier. Biography. Early life and education. Alfred Wegener was born in Berlin on 1 November 1880 as the youngest of 5 children in a clergyman's family. His father, Richard Wagner, was a theologian and teacher of classical languages at the Berlinisches Gymnasium zum Grauenkloster. In 1886 his family purchased a former manor house near Rheinsberg, which they used as a vacation home. Today there is an Alfred Wegener Memorial Site and Tourist Information Office in a nearby building that was once the local schoolhouse. He was cousin to movie pioneer Paul Wagner. Wegener attended school at the Kölnisches Gymnasium on Wallstrasse in Berlin, graduating as the best in his class. Afterward he studied physics, meteorology and astronomy in Berlin, Heidelberg and Innsbruck. From 1902 to 1903 during his studies he was an assistant at the Urania Astronomical Observatory. He obtained a doctorate in astronomy in 1905 based on a dissertation written under the supervision of Julius Bauschinger at Friedrich Wilhelms University, Berlin. Wegener had always maintained a strong interest in the developing fields of meteorology and climatology, and his studies afterwards focused on these disciplines. In 1905 Wegener became an assistant at the Aeronautisches Observatorium Lindenberg near Biskop. He worked there with his brother Kurt, 2 years his senior, who was likewise a scientist with an interest in meteorology and polar research. The two pioneered the use of weather balloons to track air masses. On a balloon ascent undertaken to carry out meteorological investigations and to test a celestial navigation method using a particular type of quadrant, the Wegener brothers set a new record for a continuous balloon flight, remaining aloft 52.5 hours from April 5 to 7, 1906. First Greenland expedition and years in Marburg. In that same year, 1906, Wegener participated in the first of his 4 Greenland expeditions, later regarding this experience as marking a decisive turning point in his life. The expedition was led by the Dane Ludvig Mylius Eriksson and charged with studying the last unknown portion of the northeastern coast of Greenland. During the expedition, Wegener constructed the first meteorological station in Greenland near Danmarkshavn, where he launched kites and tethered balloons to make meteorological measurements in an Arctic climatic zone. Here Wegener also made his first acquaintance with death in a wilderness of ice when the expedition leader and 2 of his colleagues died on an exploratory trip undertaken with sled dogs. After his return in 1908 and until World War I, Wegener was a lecturer in meteorology, applied astronomy and cosmic physics at the University of Marburg. His students and colleagues in Marburg particularly valued his ability to clearly and understandably explain even complex topics and current research findings without sacrificing precision. His lectures formed the basis of what was to become a standard textbook in meteorology, first written in 1909–1910, Thermodynamic der Atmosphäre, in which he incorporated many of the results of the Greenland expedition. On 6 January 1912 he publicized his first thoughts about continental drift in a lecture at a session of the Geologische at the Senckenberg Museum, Frankfurt am Main, and in 3 articles in the journal Petermann's Geophysische Mitteilungen. Second Greenland expedition. After a stopover in Iceland to purchase and test ponies as pack animals, the expedition arrived in Danmarkshavn. Even before the trip to the inland ice began, the expedition was almost annihilated by calving glacier. The Danish expedition leader, Johan Peter Koch, broke his leg when he fell into a glacier crevasse and spent months recovering in a sickbed. Wegener and Koch were the first to winter on the inland ice in northeast Greenland. Inside the hut they drilled to a depth of 25 meters with an auger. In summer 1913 the team crossed the inland ice, the 4 expedition participants covering a distance twice as long as Fridtjof Nansen's southern Greenland crossing in 1888. Only a few kilometers. For the western Greenland settlement of Kangersuaq, the small team ran out of food while struggling to find the way through difficult glacial, break-up terrain. But at the last moment, after the last pony and dog had been eaten, they were picked up at a fjord by the clergyman of Upernavik, who just happened to be visiting a remote congregation at the time. Later in 1913, after his return, Wegener married Else Koppen, the daughter of his former teacher and mentor, the meteorologist Vladimir Koppen. The young pair lived in Marburg, where Wegener resumed his university lectureship. World War I. As an infantry reserve officer, Wegener was immediately called up when the First World War began in 1914. On the war front in Belgium he experienced fierce fighting, but his term lasted only a few months. After being wounded twice he was declared unfit for active service and assigned to the Army Weather Service. This activity required him to travel constantly between various weather stations in Germany, on the Balkans, on the Western Front and in the Baltic region. Nevertheless, he was able in 1915 to complete the first version of his major work, Die Entstehung der Kontinente und Ozeane. His brother Kurt remarked that Alfred Wegener's motivation was to re-establish the connection between geophysics on the one hand and geography and geology on the other, which had become completely ruptured because of the specialized development of these branches of science. Interest in this small publication was however low, also because of wartime chaos. By the end of the war, Wegener had published almost 20 additional meteorological and geophysical papers in which he repeatedly embarked for new scientific frontiers. In 1917 he undertook a scientific investigation of the Tracer meteorite. Post-war period and third expedition, Wegener obtained a position as a meteorologist at the German Naval Observatory and moved to Hamburg with his wife and their 2 daughters. In 1921 he was appointed senior lecturer at the new University of Hamburg. From 1919 to 1923 Wegener did pioneering work on reconstructing the climate of past eras, closely in collaboration with Milutin Milankovic, publishing Die Klimat der Geologischen Vorzeit together with his father-in-law, Vladimir Koppen, in 1924. In 1922 the third, fully revised edition of The Origin of Continents and Oceans appeared, and discussion began on his theory of continental drift, first in the German language area and later internationally. Withering criticism was the response of most experts. In 1924, Wegener was appointed to a professorship in meteorology and geophysics in Graz, which finally provided him with a secure position for himself and his family. He concentrated on physics and the optics of the atmosphere as well as the study of tornadoes. Scientific assessment of his second Greenland expedition continued to the end of the 1920s. In November 1926, Wegener presented his Continental Drift theory at a symposium of the American Association of Petroleum Geologists in New York City, again earning rejection from everyone but the chairman. 3 years later, the fourth and final expanded edition of The Origin of Continents and Oceans appeared. In 1929, Wegener embarked on his third trip to Greenland, which laid the groundwork for a later main expedition and included a test of an innovative, propeller-driven snowmobile. Fourth and last expedition. Wegener's last Greenland expedition was in 1930. The 14 participants under his leadership were to establish 3 permanent stations from which the thickness of the Greenland ice sheet could be measured and year-round Arctic weather observations made. Wegener felt personally responsible for the expedition's success, as the German government had contributed $120,000. Success depended on enough provisions being transferred from West Camp to IJsselmeer for 2 men to winter there, and this was a factor in the decision that led to his death. Owing to a late thaw, the expedition was 6 weeks behind schedule, and as summer ended, the men at IJsselmeer sent a message that they had insufficient fuel and so would return on the 20th of October. On the 24th of September, although the route markers were by now largely buried under snow, Wegener set out with 13 Greenlanders and his meteorologist Fritz Loh to supply the camp by dog sled. During the journey, the temperature reached -60°C and Loh's toes became so frostbitten they had to be amputated with a penknife without anesthetic. 12 of the Greenlanders returned to West Camp. On the 19th of October, the remaining 3 members of the expedition reached IJsselmeer, there being only enough supplies for 3 at IJsselmeer. Wegener and Rasmus Willemsen took 2 dog sleds and made for West Camp. They took no food for the dogs and killed them one by one to feed the rest until they could run only 1 sled. While Willemsen rode the sled, Wegener had to use skis, but they never reached the camp. Wegener died and Willemsen was never seen again. The expedition was completed by his brother, Gert Wegener. This expedition inspired the Greenland Expedition episode of Adam Melfort in John Buchan's 1933 novel A Prince of the Captivity. Wegener died in Clarinetania, Greenland, in November 1930. Willemsen had buried the body with great care, and a pair of skis marked the gravesite. After burying Wegener, Willemsen had resumed his journey to West Camp, but was never seen again. 6 months later, on the 12th of May 1931, Wegener's body was found halfway between IJsselmeer and West Camp. The team that found him reburied his body in the same spot and marked the grave with a large cross. Wegener had been 50 years of age and a heavy smoker, and it was believed that he had died of heart failure brought on by overexertion. Willemsen was 23 when he died, and it is estimated that his body and Wegener's diary now lie under more than 100 meters of accumulated ice and snow. Continental drift theory. Alfred Wegener first thought of this idea by noticing that the different large land masses of the Earth almost fit together like a jigsaw puzzle. The continental shelf of the Americas fit closely to Africa and Europe, and Antarctica, Australia. India and Madagascar fitted next to the tip of southern Africa. But Wegener only took action after reading a paper in 1911 and seeing that a flooded land bridge contradicts ice to sea. Wegener's main interest was meteorology, and he wanted to join the Denmark-Greenland expedition scheduled for mid-1912. He presented his continental drift hypothesis on 6 January 1912. He analyzed both sides of the Atlantic Ocean for rock type, geological structures and fossils. He noticed that there was a significant similarity between matching sides of the continents, especially in fossil plants. From 1912, Wegener publicly advocated the existence of continental drift, arguing that all the continents were once joined together in a single land mass and had since drifted apart. He supposed that the mechanisms causing the drift might be the centrifugal force of the Earth's rotation of the astronomical precession. Wegener also speculated on seafloor spreading and the role of the mid-ocean ridges, stating the mid-Atlantic ridge zone in which the floor of the Atlantic, as it keeps spreading, is continuously tearing open and making space for fresh, relatively fluid and hot seama from depth. However, he did not pursue these ideas in his later works. In 1915, in The Origin of Continents and Oceans, Wegener drew together evidence from various fields to advance the theory that there had once been a giant continent which he named a continent. Expanded editions during the 1920s presented further evidence. The last edition, just before his untimely death, revealed the significant observation that shallower oceans were geologically younger. Reaction. In his work, Wegener presented a large amount of observational evidence in support of continental drift, but the mechanism remained a problem, partly because Wegener's estimate of the velocity of continental motion, 250 centimeters per year, was too high, while his ideas attracted a few early supporters such as Alexander Dutoit from South Africa, Arthur Holmes in England and Milutin Milankovic in Serbia, for whom continental drift theory was the premise in investigating polar wandering. The hypothesis was initially met with skepticism from geologists who viewed Wegener as an outsider and were resistant to change. The one American edition of Wegener's work, published in 1925, which was written in a dogmatic style that often results from German translations, was received so poorly that the American Association of Petroleum Geologists organized a symposium specifically in opposition to the continental drift hypothesis. The opponents argued, as did the Leipziger geologist Franz Kosmat, that the oceanic crust was too firm for the continents to simply plow through. Wegener's fit of the supercontinent at the 200 meters isobar, an idea he had since at least 1910, was a good match. Part of the reason Wegener's ideas were not initially accepted was based on his proposed fit of the continents, with Charles Schuckert commenting, "During this vast time the sea waves have been continuously pounding against Africa and Brazil, and in many places rivers have been bringing into the ocean great amounts of eroded material. Yet everywhere the geographic shorelines are said to have remained practically unchanged. It apparently makes no difference to Wegener how hard or how soft the rocks of these shorelines. What are the geological structures that might aid or retard land or marine erosion? How often the strand lines have been elevated or depressed, and how far penoplanation has gone on during each period of continental stability. Furthermore, sea level in itself has not been constant, especially during the Pleistocene, when the lands were covered by millions of square miles of ice made from water subtracted out of the oceans. In the equatorial regions, this level fluctuated 3 times during the Pleistocene, and during each period of ice accumulation the sea level sank about 250 feet. The comment was based on the misapprehension that Wegener's fit was judged along the current coastline, while Wegener was using the 200 meters isobar. Wegener, who was in the audience, made no attempt to defend his work. Supporters such as Dutoit also contributed to this misunderstanding of the method of the continental fitting, commenting, "Most persons view the continental shelf as an integral part of the continental block. and criticize Wegener for endeavoring to fit together the masses by the present coastlines instead of by the submerged margins of the shelves. In 1943, George Gaylord Simpson wrote a vehement attack on the theory and put forward his own permanentist views. Alexander Dutoit wrote a rejoinder in the following year. Modern developments. In the early 1950s, the new science of palaeomagnetism, pioneered at the University of Cambridge by S.K. Runcorn and at Imperial College by P.M.S. Blackett, was soon producing data in favor of Wegener's theory. By early 1953, samples taken from India showed that the country had previously been in the southern hemisphere as predicted by Wegener. By 1959, the theory had enough supporting data that minds were starting to change, particularly in the United Kingdom, where, in 1964, the Royal Society held a symposium on the subject. Additionally, the 1960s saw several developments in geology, notably the discoveries of seafloor spreading and Wadati-Benioff zones, and this led to the rapid resurrection of the Continental Drift hypothesis and its direct descendant, the theory of plate tectonics. Maps of the geomorphology of the ocean floors created by Marie Tharp in cooperation with Bruce Heisenberg, an important contribution to the paradigm shift that was starting. Wegener was then recognized as the founding father of one of the major scientific revolutions of the 20th century. With the advent of the global positioning system, it became possible to measure continental drift directly. Awards and honors. The Alfred Wegener Institute for Polar and Marine Research in Bremerhaven, Germany, was established in 1980 on his centenary. It awards the Wegener Medal in his name, the crater Wegener on the Moon and the crater Wegener on Mars, as well as the asteroid 29227 Wegener, and the peninsula where he died in Greenland, are named after him. The European Geosciences Union sponsors an Alfred Wegener Medal and AMP honorary membership for scientists who have achieved exceptional international standing in atmospheric, hydrological or ocean sciences, defined in the widest senses, for the merit and the scientific achievements. Selected works. Wegener, Alfred, Thermodynamik der Atmosphäre, Leipzig, Verlag von Johann Ambrosius Barth. Wegener, Alfred, Die Herausbildung der Großformen der Erdrinde auf geophysikalische Grundlage, Petermann's Geographische Mitteilungen, 63-185-195, 253-256, 305-309. Presented at the annual meeting of the German Geological Society, Frankfurt am Main. Wegener, Alfred, Die Entstehung der Kontinente, Geologische Rundschau, 3, 276-292. Bibco, 1912 Joru, .3, 276 W, DO 10.1007, BFO 2202896. Wegener, Alfred, Die Entstehung der Kontinente und Ozeane. ISBN 3-443-01056-3. LCCN Unc 83068007. Wegener, Alfred, Die Entstehung der Kontinente und Ozeane. Braunschweig, Friedrich V. Wegener Amp, Sone KT, GEs, ISBN 3-443-01056-3. English language edition. Wegener, Alfred. The Origin of Continents and Oceans. New York. Dover, ISBN 0-486-617-084. Translated from the Fourth Revised German edition by John Birham, British edition, Methuen, London. Koppen, W. and Amp. Wegener, A. Die Klimat der Geologischen Vorsicht Bornträger Science Publishers. English language edition. The Climates of the Geological Past 2015. Wegener, Elsie, Low, Fritz eds. Greenland Journey. The story of Wegener's German expedition to Greenland in 1930-31 as told by members of the expedition and the leader's diary. London, Blackie and Amp. Sun Limited. Translated from the 7th German edition by Winifred M. Deans.